G'day, I'm Alister Christie from LearnDelphi.tv. This is my website, and I have a large number of free videos that you can look at. They're all on YouTube, and they're on various random topics. If you're after something a bit more structured, I have some premium content, videos I have for sale, which is available on the Embarcadero Academy website also. In this video, we're going to have a look at the RTL, and I've just chosen a bunch of random topics, which hopefully some parts of the RTL that are perhaps not as well recognized, and you should be able to take advantage of to save yourself a bit of coding time and effort. So let's get straight into it. I have here a couple of functions that we're going to improve, or at least make more concise, and we will start with this one. So it's the basic if statement. So if the value is 0, we return 0, otherwise it's non-zero. So very simple, somewhat meaningless function. So we've got two overloaded functions for doing sort of this and sort of the reverse. I'm going to need to include system.streetutils. I'm not sure why that wasn't auto-completing, but the uses auto-completion's never been particularly good. What I'm going to do is replace these 4 lines with a single line. And that single line is if then our function, and we return 0 if it's true, and if it's false we return non-zero. And of course we need to modify this to make sure it does actually return it. And if I'm being pedantic, I will do that. Now, if we control click on that, this function basically does the same thing. I suspect, yes, there we go, it's inlined, so it'll be just as efficient. But I think that can be easier to read and more concise, provided you're familiar with if then. It's also used, it's quite a common function in various programming languages. It's kind of Delphi doesn't have the ternary operator for that, so this function works just as good. And it's probably easier to read actually. Now, we can do the same for this function, but first of all, if we take a look at this, we see that this is doing a case-insensitive comparison to 0. So no matter what the case of 0 is, it will return true, provided the string is 0. Now, there's a better function for that, and that's same text. So that will do exactly the same. And I'll control click on that. And we see that it compares 2 strings without case sensitivity. And there are 2 variations on it. One of this locale options, which we won't go into. And if you want to be case sensitive, there is also same-str. These also compare text, which returns an integer. So if it's, I think you can read the description, but if it's greater than, it returns 1, I suppose, and less than -1, and it's the same 0. So that's also useful. In fact, there's the description there. So same text is much better than using converting the string to lowercase or uppercase and then doing the comparison. And we want to take, well, in fact, let's just copy that one. So if then, don't need that anymore. Comma 0. And those are redundant. But of course we need to actually return it. Now if I compile this will actually fail, because if then, so this if then returns strings, and this one we need to obtain from system.math. And if I control click on that, we'll see that there's in fact that's not going to, so let's go control enter on that, search for if then, and we see there are a whole bunch of them for different kinds of numerical types, so integer down to extended. So I rather like if-then to avoid the simple if statements to return different values depending on what you're wanting to compare, and that's much more, it's more concise. I think it's easier, personally I think it's easier to read, and if you want to construct horrible assignment statements you can sort of include this in line with a whole bunch of other things as well, but I tend to like break things up a bit to make it more readable. I might talk about that a bit later. I'm now going to take a little bit of a digression from the RTL. If we go back to our code and just control click on that. No, let's get back into math. And I'm just going to copy and paste that to there. And remove the math unit for now. So this should now more or less compile, except let's take that and throw that up here so that it appears before our new function declaration. Let's get that to compile at least. Right, so there are probably lots of other types that would like to be able to use this if-then function on, and we can take advantage of the generics in Delphi. So I can make it parameterized, the function, and so those integers become t's, and now we have a generic version of the function, except it won't compile because types are not allowed on global procedures or functions. So that's not particularly helpful, but what we can do, generic utils equals class, and I can define a class function, and we'll copy that, check that there, and that at the very beginning. And that should actually mostly compile, except for the fact that we need to say if-then integer, and it has to be generic utils dot. And now we can do it with any type we like, you know, T-buttons or forms, or any kind of, yeah, even a Boolean if we were particularly mad. But you'd probably want to create a new unit and chuck that in. Might call this unit, you know, generic abc.utils or something like that for or whatever your company or project name is. And so just throw that in there, and we need that in the interface. And unit 7. So we've now got a reusable unit, although you'd not call it unit 7. For this next example, we're going to stay with the stray utils unit, and we have this function isCommand, and basically it checks to see if the first 3 letters of the command string are CMD, and it of course is doing it in a case insensitive manner because we're using lowercase and comparing to a lowercase string. But in stray utils, and I like to do the fully qualified version of it, and there is a starts text, and we'll no longer need the lowercase function because starts text is case insensitive. Let's control click on it, and we see it calls ANSI starts text, but the comment is that yeah, so it basically does the string begin with the substring, and we have 2 versions of it, and there's also a contains text for something in the middle of the string. So my personal feeling is that is a better version of the function. It's more easily understood at a glance, which is what you want. And so I think that is now easier to maintain going forward. Next up, we want to have a look at the match text function. And in this little process command function, we see that there is this if statement, which looks a little bit horrible and hard to see what's going on, but there's a comment. If the command string is open or the priority is not set or high, we do something. So what I would do is split the if statement up into the sort of two components and have what's called explaining variables. So I take that there and throw that in, copy that, and declare a variable for that, and take that lot and I might just throw that on one line for now. So we can see that if is open command and priority is not set or high, we do something, and this is basically what this comment says. So we actually no longer need it. So we've improved our code and made it easier to understand. Removed a comment, because comments are bad because you end up having to maintain them, and generally the code gets maintained and the comments get ignored, and then eventually the comments end up saying something completely different to what the code's doing. So if you can avoid having comments, I highly recommend trying to avoid them where possible. Of course, they're great for explaining the sort of intention of code, but not the little specifics that is, every little thing that it's doing. That just becomes a maintenance nightmare. So that's sort of a little refactoring before we get started. I did this video, I should mention this video is actually on YouTube, this section, and is reasonably popular. Got quite a few comments on it, so I thought I'd include it here. And I think it was more about this refactoring, that you should be write good code. You write it once and you have to maintain it forever. So the maintenance is the expensive part. So writing it, you can spend quite a bit of effort making it as maintainable as possible, and generally that will pay off in the end, if you have the time available, of course. So this is open command. We see that we've already seen that this will we can replace this with same text, but there is also a function called match text, which takes a string as a parameter and an array of strings and just clean that up. Oops. We've now got too many. Okay, so if we have a look at match text, and we can have a look at the comment, we can oh, it actually doesn't actually say anything particularly useful, but maybe the ANSI match text. Okay, dealing with strings. So basically it is if this command appears in this array, it will return true. And this is quite a useful function. I use it fairly regularly for checking if strings, checking that kind of standard OR pattern. It avoids that, and it's much more concise and much more readable, particularly if you're wanting to determine if it's one of quite a few strings. So that's match text. There is a match str as well. If case sensitivity is important, and that will match only if it's an exact match. So I think those are I've probably covered the most useful functions that are not well known in the StruUtils unit. We'll probably move on to something else next. Next up, we're going to have a look at zip compression in Delphi. Now, zip compression is I'll say, recent, in air quotes, addition to Delphi. I think it was introduced in about Delphi XE2 or so. And it's in the system.zip unit. And I'll just Control Enter on that. And the two functions we want to look at are this zip directory contents and extract zip file. Now, these are class procedures. So we need to do zip first. So we can go T zip directory contents, and we need a zip file name and a directory to zip. And if we run that, and I'll just bring up that in the background and go zip directory contents, we see it's created our zip file, and it's still busy processing it there. It's done. And we also want to be able to do the reverse, which is unzip, and there is a similar extract zip file, and we need to specify the zip file name and again somewhere to extract to, in this case source new, and we can run that. And go unzip, and there we have our source new, and we can delete those. So that's with just those two functions, you can achieve quite a bit with zipping and unzipping. They're the two sort of biggest use cases. But you may want to be able to do a lot more, and I'm just going to do a shameless plug here, and that is for my video course, which is still incomplete, on zip compression in Delphi, which is also included in the Mega Pack. So as you can see there, it's available, and the value of this course is quite amazing. If you look at other video courses online on O'Reilly or Pact Publishing, they're usually $100 for about a 4-hour course, and they've got sort of 34 hours. I think it's probably more than that now, because I think the zip compression is quite a few hours. But anyway, enough sales pitch from me. But that's zip compression in Delphi at a very high level. So I have here a very simple application. It is basically just a list view, and I've set the view style to report, and I've created a number of columns. And this is going to be a list of elements. And here I have our list. Now, it's basically a CSV file. There is actually some data missing, but we're only concerned with the first 4 items, and we're going to read that in to our application. So in our form create, we'll do the processing there, and what I'm going to show you in this video is how to use a string list to process CSV data. So we're going to need 2 string lists. We have element and elements. And dot. Oops, I lost my selection. Okay, that'll be nice and tidy, and free those. It's unlikely that anything's going to go wrong with this create, so I'll use this single try finally. So we want to load our string list, and I will just copy the file path. Now, this is the interesting part. So the comma text property, if I assign that a line from our string list, so do a for loop from 1 to count -1, and it's from 1 because our first row contains our descriptions. So we want to loop from hydrogen down. And I'm just going to assign that our elements I. And what that's going to do is going to break apart our row and create a string list where each of these items is a separate line. So that's pretty straightforward. And then we just want to add, yeah, that's called list view 1. Yep. Add an item. So Control-Shift-V on that. And set the caption to the first value, and we want to set the sub items to be the remaining 3. And if I delete the first line of our element, I can then just go sub items dot assign element. Now I think I've got enough there, so we run that. And there we go. Our list of elements from hydrogen all the way down to lawrencium. I even got my columns in the right order. So that's using the comma text property. There is another property. Let's in fact leave that like that for now. If hydrogen happened to be 2 words, hydrogen, what the comma text property would do would actually break on that space as well as the comma. This would have to be quoted like so for that to go in as a single value. So what you can do is say element dot strict delimiter is assigned true, and that won't break on spaces. The other issue is you might have had a tab delimited file, so instead of commas you get tabs, and so you wouldn't want to use the comma text property, you'd use the delimited text. And you also want to specify a delimiter, which I think is comma by default. Like so, and that should still work. And indeed it does. But I think for delimiter, I think it's #9. I think is a tab. I have to look in the ASCII table. But that is using a string list to process comma delimited data. While we're on the subject of reading CSV files, we might want to read the CSV file into a dataset. In which case we can throw on an FDMM table, and if I just call that elements, we'll need a data source. Something for displaying our data, and if I'm being picky, and to finish off our GUI we need a button, and I'm just going to align the button to the top give it a caption of execute, and let's align this to client. Now, to load a CSV file, we can load a batch move, and for that we'll need a reader and writer. So we can use a text reader, and we'll need to specify the file name, which is our elements. CSV file. We'll need a dataset writer and point that to our elements table. We're also going to need a wait cursor. And I'll throw an exception if you try to run it without it. And we need to set up our reader and writer, which has already been done automatically for us. In our execute, just want to call execute, so we've written one line of code. And if we run this, it's going to fail for one reason. There's an extra field on the end here, which I just need to specify. I actually don't know what it is, so I'll save that. And we can change one more property, which is analyze fields. And if we run that, there is our FTMM table loaded with all the elements. And I think we need to specify a bit more for our analysis. Let's make it 200. It'll analyze everything. And there we have our list of periodic table, or our list of elements in a data set, which we can then do whatever we want with. There is, of course, a lot more to batch move. There's a lot of flexibility, like if I want to manually specify the fields, I can do so in here, rather than calling it element. Make it name, and menu specifies a string, field size 20, and so on. In fact, this won't have any effect at the moment because analyze fields is turned on. And we'll at this point get some bizarre behavior. As you can see, it's putting everything in one column. But there is lots and lots of flexibility, which I'm not going to go into because we don't have time. So I have this little application here, which loads up a list of elements, and we can select a bunch of elements and go show symbols, and it does show symbols. So very simple. And in the method, it's basically we disable the controls on the data set. We remember the record we were on, and then we loop through all the selected rows, and we go back to the record that we were on originally. We enable controls, and then we do our show message. That's pretty simple and nothing special about that. And we're asked to write a new method, and we'll need a button for that, which is some numbers, some of the atomic numbers. And before you ask what possible use could some of the atomic numbers have, you say sure. Now, of course, the bad way of writing this is to take all of this code and copy and paste it and throw it in here. But we're not going to do that. We're going to use anonymous methods to wrap up all this code in here into a single thing, and then basically we can execute something arbitrary in this part. So what I'm going to do is I'm going to come up here and write a function or procedure for every selected element, and we're going to pass in an anonymous method. So use Control-Shift-C to do that, and what I'm going to do for now is just copy that, and in here, rather than executing our little thing to be able to share the message, we're going to call proc, and I'm just going to eliminate that. So this code then just becomes, we eliminate all of that, and we no longer need the bookmark or integer, and I suppose in here we don't need symbols either. And we call for every selected element. Let's start on a new line. And throw that in there. And I think that should work. Let's verify that we still get our symbols. Yes, we do. And now we can write our some atomic numbers. Probably doesn't need to be in 64, but initialize it to 0. And what I will do is copy and paste this because I'm lazy. But we're copying and pasting a lot less. And I think we're only going to need one sum by and I think it's number. So that's pretty much, I think, all we need to do. So 0, none selected, select a bunch, 37. So that doesn't indeed seem to work. So that's basically using an anonymous method, and that's quite handy if you're wanting to wrap the outside of something and customize what's in the middle of it, because that can be quite fiddly to do if you're not using anonymous methods. Now, I suppose anonymous methods aren't actually part of the RTL, but I thought I'd just like to do an example with them as part of a demonstration. I have this application here, which you may have seen before in one of my other videos. It's a application for generating the Mandelbrot set, and we can see that the calculation time is about 1.3 seconds. Let's recalculate that again. So 900 milliseconds, and it's going to be around that. With the screen recording going, it affects the calculation time a little bit. Now, this application, in fact, if you have a look at my movie 116, this is a talk I did for the ADUG Winter Symposium in 2016, and you can watch the sort of YouTube video here, and basically I talk about building this application. In fact, I demonstrate building it from scratch, so it's definitely worth watching if you're interested in sort of writing some or doing some optimizations to code. But the calculation it was using the parallel programming library, using a for loop, and that parallel programming library is in system.threading. So this is what this section of the video we're going to be talking about, writing a parallel for loop. And we'll see we've actually got two for loops here. There's an inner loop and an outer loop, and we're going to change this outer loop so that it executes on multiple threads. And if we take a look at my CPU, it's kind of an older CPU. This is my laptop, which I've had for a few years, and it was secondhand when I got it. And it's got 2 cores which are hyper-threaded, so that gives us 4 logical cores, and you can see we're using 27% of the CPU just by doing the screen recording. So we are going to optimize this and see if we can get better than about a second on the calculation of the fractal. So let's go back to our source code, and rather than doing for, we're going to do tparallel.for. Now, it has a few overloads. I believe there are 32 of them, which is quite extreme. And we don't actually need the ampersand there. We can survive without it. So what we need to do is provide a start value, a finish value, and then an anonymous method and the anonymous method needs to take one parameter. Actually, it can take more than one parameter, but this is what we're going to start with. And we can actually leave off that begin, and let's indent that to there. So we're now, this will split this up into multiple threads, and for us automatically, and it does a lot of determination to work out whether how much CPU you've got available and stuff like that, and it'll schedule an appropriate number of threads to do that. There's also a stride parameter which we can include. It'll be one of these ones, things we're using integers to say how to break up the for loop and how many chunks to break it up into. But for now, we don't need y anymore, and this x we need to shift up into here. Now, this if cancel exit will only terminate the, well, let's see if this runs first. And you'll see rather than it drawing from top to bottom, it was broken up into some chunks, and it still took about a second, and so half a second, thereabouts. So it's going to vary a lot depending on what's happening, but we've approximately doubled the performance of the calculation. And this is, of course, I've only got 4 cores available, and technically there's 2 cores in the hyperthread, and hyperthreading adds about 25% extra to the performance, depending on the generation of it. If I did this on my desktop, it's got 14 hyperthreaded cores, so it would be able to split that up into far more chunks. So this if cancelled exit previously exited the entire method, but what we really want to do, but now it's only going to exit this procedure. So what we have to do, let's start by throwing a begin and end around that, is this will break out of our inner for loop, but we also want to break out of our outer for loop, and we do that by adding an additional parameter to this. I think it is that from memory. parallel.loop state. Yep. And then we can say break. And of course we have to do this one first, because if we swap those, this would never get executed. And so that allows us to break out of our for loop early, which is quite important to be able to do if you are running anything sort of significantly long running that you want to be able to terminate early. So I will mention one more thing, and that is the stride property. And we'll try 100 in here, and that can affect the performance of the for loop. So when it breaks your for loop up into chunks, it hands off to a thread a number of values to iterate over. So I could make this 1, and therefore each thread would execute 1 loop, or 10. Each thread would get 10 loops to execute, or 100. And it does affect performance. So it is worth experimenting a little bit, but it's going to depend on the CPU. So that's 1.2 seconds, 600 milliseconds, and so we've actually decreased our performance. Let's try 10. But it is going to depend on what the threads do. So yeah, 500, yeah, 400, that's kind of the lowest value we've seen so far. But yeah, so lots of flexibility. The for loop, as I say, there's 32 different variations on it, depending on what you need to do. So it's pretty excessive, but at a minimum, you just need to provide the procedure taking some sort of integer value, or in 64. So I could probably talk a lot about the parallel programming library, because there's a lot in there. There's also, let's look, the calculate. We can see I'm also using a task which runs this in the background, so that the user interface isn't blocked by the calculation process, because the parallel for loop, while it executes on multiple threads, is still blocking. It behaves the same as a regular for loop, so this code won't get executed until the entire for loop has been completed. So that's probably all I need to say about the parallel programming library. It's quite large, there's lots to it, and you can significantly improve the performance of your applications and make your user interfaces a lot more responsive. And in my zip video, which I mentioned earlier, I do a lot of stuff in the background using ttask. So it's a good opportunity to learn about that, because a tzip file is also not multi-threaded. So it's good to be able to run that in the background, because it can take a long time to execute. Anyway, I'm digressing. Let's move on to something else. So I have here this little application, and it's using a net HTTP client. So this is a native HTTP client, fairly recent in Delphi, and doesn't use ND, so it doesn't for doing SSL, it doesn't require any DLLs and things like that, which is why it's such an important addition to Delphi. But basically, I am downloading this web page, and then I'm showing it as a string. And if we have a look in a browser, basically this shows you what my IP is on the internet, my external IP, which I probably shouldn't be showing you, but anyway. And we can execute that, and there we have the IP, and I could probably parse it out from that, but we won't worry. But then you might ask the question, how long does it take to run that request? And there's a number of ways we could time it. We could use tdate times or get tick count, or other methods for determining that. But there is actually a library now that we can take advantage of. Now that library is in system.diagnostics. Let's control enter on that, and the main thing in there is really the only thing, tstopwatch. So let's have a tstopwatch, and in here we can go t-stopwatch.start new. Oops, it should be SW. And we can have a look at elapsed time in milliseconds. So rather than showing the IP, I can just do that. So let's run that, and that'll tell us how long it took to run that request. So almost a second, 949 milliseconds. So the next question might become, can we get better accuracy than a millisecond? And the answer is yes. So if I swap this over, we get the elapsed ticks, and then divide that by the, I think it's ticks per second, and then multiply by 1,000 to make it in milliseconds. And if we run that, oops, except we don't want a breakpoint. Let's try that again. So just over 655 milliseconds, 673, and so on. And we can set a breakpoint on that and look at those values. There's our elapsed ticks, and there are lots of them. Is that 6 billion or something? I don't know. It's large. 67. Yeah, I think it's 67 million, and the number of divided by that is also a large number, ticks per second. So there's quite good resolution, and we might go something like that on the to get more decimal places. I'm not exactly sure how many decimal places is accurate, but you probably don't need more than, generally speaking, more than two decimal places on milliseconds. Now that's a bit of a mouthful. We can actually replace that with elapsed dot total milliseconds, and according to the documentation we need to call stop, but I didn't have any problems with not including it. So that's a little bit easier to read. So elapsed returns a time span, which has lots and lots of methods that you can use to do various calculations. And that's, I think, pretty much all I wanted to say. In fact, we'll take that out, ignore the documentation, and it still seems to give reasonably sensible values. But anyway, that is the System Diagnostics unit. Thanks for surviving to the end of my video. I hope you found it useful and I didn't ramble on too much on random topics. I tried to give a wide range of bits and pieces from the RTL that you might find useful. I guess now we move to the live Q&A section.